Okay, so the next two papers are very practical in nature. The first is going to describe a real-world journey that was undertaken to understand the state of the 2110 ecosystem as was before embarking on a major new live production facility. So Willem Vermoest is the EBU's topic lead on the transition to IP-based studios, 20 years of experience in broadcast. He's most recently been working with a JTNM tested program, which I hope many of you are familiar with, and he's been instrumental in kickstarting the EBU's open source LIST project, which is their live IP software toolkit. If you're not familiar with that, you will do after this. So, Willem, over to you.
So thank you for the kind introduction. I have two handicaps here. No, maybe three. It's after lunch. I came after a brilliant presenter, Andy. And first of all, I'm not Félix Poulain. Probably you would have expected to see him to talk about the CBC test plan. So sorry, you're stuck with me today. So where do we start? Let's see. First of all, let's take a story back into time and look at some new builders. So at EBU, we have a group called the New Builders Group, and we look into whatever they need to struggle because they not only have to buy new technology, they need to look into workflows and that sort of things. So probably you recognize a few of those buildings. The right top-hand side, that's the CBC facility in Montreal. The left top-hand, that's BBC in Cardiff. Left bottom, probably you don't know this one, that's TPC SRF in Zurich. The right bottom one, for the first one who comes to the microphone and says what broadcaster this is, I'll pay you a beer. Thomas, you know, of course. We'll get back to this, by the way. So what's the story here? Many broadcasters, they built their buildings in the early 60s. So financially speaking, their buildings have been written off. And that's how those stories start. It's efficiency exercise from the facility people. So those buildings start to cost too much, and you need to think, well, shall we refurbish or shall we build from scratch something totally new? By the way, the background that you see here, that's probably the fourth picture, that's the VRT RTBF building in Brussels in Belgium. This building is known to be the radiator of Brussels because the heat goes more outside of the building than inside. And it's called also the radiator of Brussels because the nice decoration elements on the front side, well, they look more or less like a radiator, and be mindful, if you're ever there, they tend to fall off the facade of the building. So actually, we mapped those new buildings throughout Europe. So let's have a quick look. And you see the typical curve of new technology, so the enthusiasts, the visionaries, the pragmatics. And I try to build this more or less in a way that we would say that 2110 and those technologies would map. So first of all, we saw a lot of proof of concepts throughout Europe. That's, of course, the BBC guys are first with their Viler project, the Commonwealth Games. There was the VRT EBU proof of concept based on 2022-6. RTS did a few, and France Télévisions did a proof of concept of 3. So that's a lot of pre-work in order to see if the technology would fit for a broadcast facility. Then the yellow boxes, they depict already new buildings. So there's RTL City Live, that's BCE in Luxembourg. That's the first building I know of that's been using 2022-6, and it's completely IP-based. TV2 Norway, NRK. You see there's a lot of them on this map. On top, you see RTE and RAI. They don't build a new building, but they need to refurbish a lot. By the way, that's not all of them. We have more than 32. That's a nice power of 2, so this is why I recall 32 new buildings, so that's a lot of work. This is why EBU tends to put a lot of effort in this IP work. Now, what's important, that's these three guys. They're already on the front. You saw the pictures of those new buildings. That's BBC Wales, TPC SRF in Zurich, and CBC Montreal. These three broadcasters paved the way for all the other members of EBU. So, of course, the presentation talks about CBC, so let's dive into this story. And there's an important point in time, that's 2015. If you plan a new building, it's not yesterday that you start planning, it's years before. So before 2015, they were planning their new building, they were looking at the current financials, so they planned a building which is a little bit smaller than the current building. And in 2015, something magical happened. The new government said, we need to fund more the public broadcasters. That's very good of them. So, important choices needed to be made. This guy, that's François Vaillant, he's the Executive Director of Engineering Solutions at CBC. And, well, he had the difficult task at that time, 2015, to decide what type of technology will be built in this new facility. As you would expect from a director, he gives the direction and he says, well, look at the economical reality of today. You see the small blue bubble in the circles here? Oh, the pointer doesn't work, but you see the small bubble. That's the broadcast industry. That's about 51 billion of revenue each year. So that's how big we are. Compared to the telecom industry, we're not too big, but compared to the complete IT industry, which is 3,500 billion revenue a year, we're small. This means in reality, and you see meanwhile the graph of the speeds of development in SDI technology and IP technology, IP goes much faster. That's, well, everybody knows this by now. And to give a small example, the one IP link at the top right, it can have plus minus 40 uncompressed UHD streams or 400 uncompressed HD streams, while at SDI, well, it's still one single, right? And to make the graph even more interesting, this is logarithmic. If you look at the linear scale, it looks like this. So with this in mind, François Vaillant said, well, we were asking ourselves the question, would we go to IP or not? No, it's not a question. Would we be the last to have a facility with SDI? If we start building now, it will probably take years that we're stuck with this. Or will we be one of the first to implement 2110? It sounds a bit negative, but it's lost in translation. It's not even a choice anymore. He said, well, it's the obvious choice to go to IP. There's no other choice that you would take with a sound brain at this moment. So let's take a look. This is a magnificent picture, right? It's full of colors. This is how the building should look when it's completely finalized. And there are some facts and figures of this new building. It's smaller. It's still 420,000 square footage of floor space, 11 new studios, 4 automated control rooms, 3 multi-purpose television studios with 2 control rooms, 18 radio studios, 12 of them are self-operated, 40 television channels, 40 web streaming channels, 160 radio channels. And to give you an idea about the network that they think that they need to have, that's 450 terabit per second. That's quite impressive, right? So, all of this in mind, they need to go on air in 2020. So they need to move to a new facility, completely new, so new for everyone. If you come at your desk, there's a new phone, a new PC, new everything. There's a technological shift from SDI or IS EBU or even analog audio to audio over IP and video over IP. And it's not just a one-stop shop project. It should be multi-vendor and it should be fully interoperable. So you can ask yourself the question, what could possibly go wrong? Maybe something like this? Well, of course, that's not what you want. So this is why Félix Poulain, he's the director of the engineering lab, he said, well, our goal is to reduce the risk of the project. And we do this by learning everything about IP networks, PTP, SMPTE 2110, the whole standard suite, the AMWA interfaces and specifications, and we try to put the theory into practice. And this is where you get the most learnings. So what does it mean? They built some sort of a test plan, and the test plan, it looks nothing more than a spreadsheet, so it's quite obvious. It's based upon all the standards, and as one of the guys told me in a previous panel, it's not just one standard like SDI. Now you need to have a full stack of standards. If you look into, well, 2110 and then all the RFCs you need, it's a full stack. And they made the template modular. So whenever they need to go and go for their procurement procedures, you can take parts and bits of the test plan. The added bonus to the test plan is as well that this thing serves as a communication tool for the technical staff. So how does it look like? Pretty simple, just an Excel sheet. It's pretty small to read, so I'll make it bigger. There's a title, there's the equipment to be used to do the test procedure, and the expected results. It's, of course, much more than this small spreadsheet. So they're looking into several things. if you talk about PTP, they have a brilliant expert, Louis Lamar. He can talk hours and hours about PTP, how they built a redundant setup. So this is just one small part of the plan. It's all equipment should be compatible with the IS R16 profile. Multicast or hybrid, lock time, lock state, BMCA, and the list goes on. This is just scratching the surface, right? My favorite one, and Andy, you start to laugh probably. I dream about packet pacing, so sorry I have to mention this again. There's a -21, of course, the traffic shaping. There's -20. Well, all of the things that you can imagine, they're on this list. So, of course, you can do a theoretical test plan, but it's nothing if you cannot put this into practice. So they have a small test bed. The test bed is nothing more than a spine leaf architecture. In the middle, you see the spine. On the top hand, you see a purple switch. They found it logical to have a purple switch to have accommodation for devices that you can not use with a redundant stream, so no -7. So typical devices you would see here, that's embryonics, encapsulators, and decapsulators. On the left bottom, you see a switch with a packet storm VIP system, Tektronix. They made their own FFmpeg implementation with an NMOS wrapper around it to do some transcoding. The yellow box is the device under test. This is where they start testing the box. If it has an A and a B network or an amber and a blue, you see it's on the same switch, but it's in a different VLAN. And if there happens to be a management interface, you see the wire going to the green side of the network. That's where the management VLAN is. On the right-hand side, you see things like the AMWA NMOS test suite, a very interesting piece of work, DNS, DHCP. Of course, you need a PTP clock at some point, and the NMOS registration and discovery service. So this is their nice test bed, and with the test bed, they do all the fine learnings. Now, what is the problem they need to fix? Well, they have a lot of test tools. Not all of the tools are here shown on the little graph. They have even an Ixia. That's a big network device to create jitter on the network to see if all the tests for -7, for instance, if they work out properly. So the time to test a device under test, it's too much. If they need to test this much of equipment that they need to test, they need to speed up. Otherwise, they cannot get the job done. And besides of this problem, there's also the Tower of Babylon issue, because everything is named a little bit different. So let's dive into this. But first of all, I need to talk to you about this nice pyramid, and I don't know how many are aware of the EBU technology pyramid for media nodes. I see a few hands, so that's a good start. So maybe I'll just quickly go over it. The tip of the pyramid, that's the green nice tip, that's the media transport. So in the media transport, you find 2110, the -21, -30 level C audio, that's what they want, and stream protection with 2022-7. That's green because that's out there and it works. No issue at all. The second layer of the pyramid, it's what we call the time and sync layer. That's where you typically look at PTP, multi-interface PTP redundancy, and that's not always there yet. Synchronization of audio, video, and data essences. Andy mentioned that with the new revision, it's becoming possible to have this automatically. That would be wonderful. The third side, discovery and registration, it's yellow as well. And it's not yellow because the specifications are not out. Probably the specification ISO 4 was even released before 2110. But the problem is those things are not yet widely available in products that you buy. So that's an issue. You find things like discovery, registration, connection management, audio channel mapping, LLDP in this type of layer. Then we get more to the red zone, and CBC was very firm on this. This is a red zone, because one of the most important things is, well, while you plug something, it's out of this world that you plug it and you need to configure an IP address. I hope nobody that got onto the network here needed to configure its IP address. You assume you get one of the network, right? Well, we should have the same in our broadcast facility. It's so easy. Not there yet. But there are other things as well. It's not CBC in Montreal. They have a lot of buildings throughout Canada. So if you want to connect remotely to a site, you expect that there's a control protocol that you can use throughout all the products, and that you're not for just each product, you need to have another type of console or SSH or CLI or whatever that's out there. And then the big pitfall that Andy mentioned as well, there's a lot of work that can get into this one. But it's very hard to sell because you don't get that extra functionality, but you get some sort of risk reduction. That's security. So why is this important for the test plan? You can look at the test plan in different phases. Oh, by the way, before I forget, the blue things you see on this map, this is brought to you by the JTNM TR1001 document. So in this document, it describes how you can build facilities on a scale like the CBC facility with other things that complement it, like ISO 4, ISO 5, DHCP. So that's a very important document. If you happen to be building, please download the document. It's for free to download, read it, and maybe attach it to your tender. So if you look into testing, there are a few layers. There's the data plane, that's 2110. There's the control plane, that's NMOS. And that's fully in the TR1001. And of course, there's the security testing. Now, the Tower of Babylon, I need to give this schedule here. The Tower of Babylon is nothing more than different namings for different things. On the top-hand side, you see what's written in the standard. That's the packet read schedule. And actually, the packet read schedule, it describes, in theory, it says each packet is sent over the network according to a packet read schedule, right? So at the perfect timing, the first packet of the frame is sent at TVD. TVD is n times t frame plus TR offset. So when we were testing things, and even at the interop events, we were saying, oh, I measure a different TR offset. Some other guy came to me and said, how can you measure a different TR offset? A TR offset, it's a fixed value in the standard. Or it's given at the SDP file. You cannot measure it. It's something out there. You measure something else. You measure the practical value. I said, OK, I understand what you mean. We actually mean the same thing, but you want to call it different. Also, the first packet, is it TPR0? No, that's the theory. But it's the arrival of the first packet. So this is why I thought, well, let's make a second line here and use some namings to prevent our Babylon effect. So to give a few examples, if you want to do some measurements, let's see. Some people call it the video timing. That's the difference between the first arrived packet, TPA0, and n times t frame. Some people call it video timing. There are other names. There are tons of names. You can talk about RTP time, the time that the RTP timestamp refers to, compared to the reference time. That's how I call it. Some people have the calculation in a different way. They even say, no, it's n times t frame minus RTP timestamp. Why would you do that? Anyway, it's some sort of a discussion that's endless. We just need to agree on a few words. And let's give the few words that are out there. So for video timing, there's video timing, video to PTP, PTP to video. First packet timing, it's a zoo. So let's agree on some words. And if you agree on some words, it's so nice for your project. Suddenly people can start to talk to each other. That's really lovely. So this is what I mean by this. Now, what did we do as EBU to help them a little bit? We have something, we started 2 years ago, and I think last year I talked about the open source Live IP software toolkit. And it's a software-based 2110 analyzer. It's open source. You can download it from GitHub. We do have a Docker container, so that's not a big issue. And for the members who are working and collaborating in it, it's an agile software development process. That's a trendy word, I know. This actually means that each week we come together on a call and we discuss what the user needs are, what are the user stories that we need to build on. And of course, we do have long-term goals, otherwise you could go with your agile process to nowhere, so that's not the intent. So we have a weekly meeting, we discuss what we have developed, we discuss what we plan to develop for the next 2 weeks, we design it, and we give feedback. How does the implementation look like? Are we happy with how it looks like? And shall we go on to the next one? So the Agile methodology that seemed for us like very nice. Suddenly we were very close to our members and our users, and they were not just saying, we need to have this feature. No, suddenly they were part of building the features and also making the decision what to prioritize. And this is where it gets interesting, because suddenly everybody realizes you don't have all the time or all the budget to just develop everything. So it suddenly makes a team really work like a team. Now, what are the features we developed for CBC, and CBC also co-developed together with us in order to help them testing? One of the features here, I hope you can see something at the back about this. This is an analysis for audio. One of the things they discovered in their testing procedures was the audio that they wanted to have was everything digital. Audio over IP, also for on-stage and in-ear monitoring. But you have to be sure that for in-ear monitoring, you have to have a low delay. So they were looking into 125 microseconds profile of audio just to be sure that the delay was okay for them. But then suddenly they discovered it was not okay. Nevertheless, all those boxes they had in their test lab stated they were low delay. So this is why we added this feature, and it's nothing more than the EBU TSDF, the timestamp delay factor. There are boxes that have implemented this years before, like the Tektronix Prism has this for video. So we tried to adapt this for audio as well. So the thing we injected here was a file we created, and we ingested some artificial jitter with an Ixia in order to see how it reacts and it responds. So this is a first impression. What else did we do? They had a lot of focus on ancillary data. So closed captions, VETC, and a few other things. So we elaborated a little bit more on the ancillary data. To give an example, we had a JTNM test file, 1080i50. And we look at the ancillary data, and we can dive into the details. So we can look at the LTC or the VTC to see if everything is okay for them. So this helps them a lot. But nevertheless, there's still an issue, because if you, well, maybe first this. So what we tend to do with this tool is you don't have to be bothered by everything that's green. It's managed by exception, so you can watch everything, or you just can have the red spots where you need to take especially care about, where something is going wrong. Of course, this doesn't help you in automating tests, but you still need to look at something. This is why we thought with the CBC guys, maybe we need to create the report also as a JSON report, that you can do whatever you want later on with this, that you can start automating your test, that you just plug in your device on your test, you click the button, and there you go. So this speeds up their process tremendously. Of course, it creates a PDF as well, so they can send it back to the vendor if they want to. Another thing, and this is why I still have to insist on using NMOS and ISO 4, ISO 5, and that sort of things. We also support now NMOS ISO 4 into this tool. And to give you one practical example, during the JTNM test, the tested program in August, we invited each vendor with their product to come and sit by us and run through the whole test. And suddenly there was a guy from a brand I shall not name, and he said, really? You want me to change the IP address of my box and to change, it was -7 by the way, so more fun, the audio, the video multicast addresses, the ancillary addresses, -7, so 3 times 2, and oh, I'm source specific, so we had to change a lot of addresses. So my first and only response was, well, if you would have implemented ISO 4, it was just a click, and you would have been okay. You didn't have any work at all. This is really how it works. So there was another vendor, and we said, are you doing ISO 4? Yes, I'm available in the registry. You just search for the specific vendor, not naming the name. Everything pops up. You click on the device, and everything is pre-populated. So this helps a lot. And this was one of the early things that early adopters said to us. We need to configure manually for just one truck 500,000 multicast addresses. It's insane. So you need to have this control layer on top in order to make it work in practice. So another thing that we want to do is we want to compare the SDP file that we can get via animals as well, with a thing that we generate ourselves. So we have some heuristics in the product to measure and to learn what type of video or audio we're handling with, and then we want to compare this with the SDP that the vendor delivers us. This also gives some interesting feedback. Further things that we need to work on is some test automation, because at the end of the day, it's all about the content. And it's hard to do anything automatic with the content, but we're working on some sort of transparency test that we can try to automate this part as well. So that would be very interesting. I know there's a feedback, sorry, it's SMPTE ST 12M. Thank you for noticing this earlier on, Thomas. So a small few words over the architectural design here. So we use standard IT tools, nothing special. On the top-end side, the UI, it's built with React.js. Then the backend, that's Node.js. All the things that do the analysis, they're written in C++, just to be sure that whenever we do live processing, that we can keep up with the pace. There are two types of databases, just one for time-related events, and the other one for all the things concerning names and all the metadata around streams. And the things we added in order to go for test automation is the message broker. That's a RabbitMQ, a message bus, in order to get all the things working around it. On the right-hand side, you see the NMOS registry, and down there, that's also new, that's what we used during the tested event, capture nodes. So with a central node, with a central GUI, we can just steer those capture nodes and capture whatever from wherever in the network we want and populate our database. So if you need to do testing on your own, what about your test plan? Would you go through all the efforts that CBC has gone through to build something huge? Or might you just go to the JTNM website and download a pre-made test plan yourself? There's a huge deal of experts throughout this whole business that built this test plan for you. There are two test plans that you can download. That's the 2110, that's the data plane, and there's the TR1001, that's the control plane including. Those two test plans you can download, and you can even look at the results of the 72 boxes that we tested in Wuppertal in August at the real facilities. So don't delay and download today. What you have going to say, that's on this website. So with this being said, some conclusions. The essentials, the test bed in order to learn, that's very important. The test plan in order to deal with a high volume, create a common vocabulary, and LIST help them in accelerating the understanding of the standards and accelerating the test process in order, again, to save money and to save time. Don't start from zero, download the test plan, and you're good to go. Thank you.
Okay, wow. So half case study and half free set of software tools you can download and do your own testing, right? I think we could probably got time for one question. Has anybody out there got one question? Perfect.
Zaidan from Cine Media. Any plan for interconnecting facilities with 2110 based on the previous presentation from Andy?
Well, that's a very good question. I don't know about CBC, but I do know that there are several projects in Europe that are very keen on working with the technology that Andy just talked about. So I guess that pretty soon we will see real implementations of that.
Thank you.
Okay, well, thank you very much. Please, a round of applause.